Dear colleagues, I'm Kathrin Becker from the EAO Junior Committee, and it is my pleasure to support the initiative of the International Journal of Prosthodontics called Bring the Journal to Life. Next, Giulia Brunello is going to present the study by Batak et al., Load to Failure of High-Density Polymers for Implant-Supported Fixed Cantilevered Prostheses with Titanium Bases. Dear Giulia, can you please summarize the background of the study?
Thank you, Kathrin. So adequate fracture resistance is required to ensure good outcomes of implant-supported fixed complete arch prostheses, especially when they are used in cantilever situation. The rapid evolution of CAD/CAM technologies has led to the introduction of new materials such as PMMA high-density polymers, which are supposed to overcome the limitation of traditional resin frameworks. The maximum stress of the framework is expected at the level of the connection of the framework at the most distal implant. When T-base is used, it is expected to be at the junction of the T-base and the implant.
So what was the purpose of this in vitro study?
So the purpose of this study was to analyze the load to failure of different CAD/CAM high-density polymers and zirconia when used with T-bases in cantilever situation.
And how was the study performed?
So 5 different types of PMMA high-density polymers and 1 type of zirconia as control were produced and tested. Each sample was fixed in a universal test machine. A load in a vertical direction was applied, simulating a cantilever of 10 millimeters until a fracture was detected and the maximum load to failure value was recorded. To investigate the behavior of the load of the monolithic materials, all materials were also produced in identical sites without T-base space and without T-base and loaded with the same test setup.
Could you please summarize the main results of this study?
Sure. As it emerged from the graph, zirconia sample with T-bases presented a significantly higher load to failure values than the high-density polymer sample with T-bases, while no significant differences were observed among all high-density polymers with T-bases. Load displacement curves of high-density polymers and zirconia with T-bases and in monolithics are presented in 2 graphs. So average load and displacement from the monolithic group were higher than those from the T-base group. Moreover, zirconia specimens sustained much higher loads, but they failed with a significant less displacement than the high-density polymers.
So what does emerge from this study?
All the tested high-density polymer sample presented a similar load to failure performances, lower than what observed in the zirconia group. The loads that fractured the high-density polymer specimen with T-bases were closer to the maximum occlusal bite forces recorded in previous clinical studies. However, we have to take into consideration that the width and the thickness of the specimen were selected to simulate the worst-case scenario. The authors further suggest that new studies with thermocycling and with the use of a chewing simulator should be performed.
I hope you enjoyed the study, and a special thank to you, Giulia, and to the EAO Junior Academy and the editors of the International Journal of Prosthodontics. Thank you for this kind opportunity. Stay safe and goodbye.
Goodbye.